Okay, so I'm going to go through the GCSE Maths Foundation to Paper 3, which is a calculator paper for AQA, and it's the June 2018 paper. So I'm going to go through each question, giving detailed answers, and after watching this run through the paper, you'll be able to answer all the questions on this paper 3. So we've got a nice and easy question to start off with, worth 1 mark for question 1, and we need to calculate the value of the digit 7 in 9.17. So the point 1 is 1/10, and then the next column, the 7, is the 100th column, and we've got 7 of them, so we multiply this by 7 to get 7 over 100, which is the 4th answer. So question 2 is a bit of algebra, really simple algebra though, so we can easily get this 1 mark. So we need to solve 3x equals 2. So what we can then do is divide both sides by 3. When we do this, we get x on its own is now equal to 2 from our original equation, and now divided by 3 from where we've done our division, so therefore x is equal to 2/3. Question 3 is 1 mark again, and the question is, which of these shapes has got no lines of symmetry? So we've got 4 shapes here, A, B, C and D. Let's just go through all 4 of them and see if we can draw any lines of symmetry on the shapes. So the first one, A, just by looking at it, I can see I can't draw any lines of symmetry, so we can't go down the middle, we can't go this way, and again, we can't go through the diagonals. Whereas for B, we've got a line of symmetry here through the middle. For C, we've got one here, like so, and then for D, we've got this one here. So the only shape... Alexa, stop, what are you doing? So again, these 3 shapes have got lines of symmetry, whereas shape A doesn't. So which of these shapes has got no lines of symmetry? Circle the correct letter, so it's A. Question 4, we just need to circle the shortest length for 1 mark. So we need to convert these units into the same unit so that we can see which one is the shortest. And I'm going to convert into meters, but you could also convert to centimeters, kilometers or millimeters. But I just think by looking at these values that meters will be the easiest one to convert to. So this one's already done. This one is 110 meters. We've then got 0.13 kilometers, and we know that 1000 meters, or the 0, is equal to 1 kilometer. So therefore 0.13 kilometers is equal to 130 meters. Okay, we've then got 1200 centimeters, and we know 1 meter is equal to 100 centimeters, and we've got 12 times 100, so we've got 12 meters here. And then finally, let's use brown, we've got 140,000 millimeters. Okay, so we know that there's 10 millimeters equals 1 centimeter, and we then know that 100 centimeters equals 1 meter. Okay, so initially to find out what centimeters we have, we divide this number by 10, our conversion factor, so we get 14,000 centimeters, and then we divide by 100 for our meter conversion factor, so dividing by 100 we get 140 meters. So we can see that the shortest length is, comparing all our values in meters, is the first one here, which is 1200 centimeters, so we will circle our answer. Question 5 part A is worth 1 mark again, and we need to shade 2/5 of this grid here. So the first thing to do is to calculate how many squares we've got on the grid, so we know how many that we need to shade in. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we've got 20 squares, and then we need to circle 2/5. Okay, so 2/5 of 20, to find this we multiply 20 by 2 over 5, and this is equal to, let me see, divided by 5 we get 4, times by 2 we get 8, so this is equal to 8. So what we need to do is shade 8 of the squares, as 2/5 of our 20 squares is equal to 8. So we'll just shade this one, and so on until we've done 8 of them. And in the exam, I'd make sure to actually shade the entire square. But imagine these are all shaded completely, and that'll be enough for the 1 mark. Question 5b, we need to shade 10% of this grid. Okay, so 10% is equal to 1 over 10. So we need to find 1/10 of this grid here. So again, we'll count the amount of squares we've got. So we've got 1, 2, 3, 4, 5 along the top, and 1, 2, 3, 4 going down vertically. So the total area, or the total amount of squares, is equal to 5 times by 4, which is equal to 20. So now all we have to do is our 20 multiplied by our 1/10 for 10% of the grid, and this is equal to 2. So we just need to shade 2 of the squares, doesn't matter which 2. But again, in the exam, just make sure that you shade them all fully, but I'll just do it like that for now. Okay, so question 6 is just about taking information from the question to work out how much money Saj saves by buying a season ticket. Okay, so the key information is he wants to go to all 19 games, all 19 home games, and for each game a ticket costs £28, and then a season ticket costs £379, and gives entry of course to all the home games. So we need to work out how much money does he save from buying a season ticket. So what we need to do is work out our 19 home games that he wants to go to. So 19 multiplied by the price without a season ticket, which is 28. Just grab my calculator. So when we do 19 multiplied by 28, we get 532. So that is the cost when he doesn't have a season ticket. So then when he does have a season ticket, we need to find how much he saves. So we take the full price, take away the cost of a season ticket, 379, and when we do this, what we get is 153. So we can say that he saves £153 when he gets a season ticket. So for question 7, we need to link the algebra to the correct description, and we had the first one done for us. So this expression here is a formula, and that's because we've got an unknown variable equal to 2 more unknown variables added together. Okay, moving on to the next one, the key thing to notice here is the triple line. It's not an equal sign, this is called an identity. So this expression is always identical to this expression here. So we can join this up with identity. Okay, next one. What we've got is 3x plus 2 equal to 14. So this can be solved to find out what x is. So this is classed as an equation. Okay, so we can join these up. I'll just use a different colour. Right, moving on to the next one, we've got 3x plus 2 on its own, no equal sign, it's just 3x plus 2. So this is called an expression because we can't solve it, it's simply just a piece of algebra, and we call that an expression. Okay. And then the final one, the key thing is this sign here, it's an inequality sign. So of course the final one here is an inequality, and I'll use brown. So they are all the answers for this question here. Okay, so question 8 is worth 2 marks, and we are told that Jim has got 6 banknotes and the value of each note is either £5, £10 or £20. Okay, we are then given some statements, so let's work through them one by one. So we are told that he can make £20 with 3 notes. So the only way that this is possible is to have a 10, a 5, and then another 5. Okay, there's no other way that we can make £20 with 3 notes. The second statement says he can make £55 with 4 notes. So again, the only way this is possible is to have a 20, a 20, a 10, and a 5. There's no other way of doing that. Okay, so if we just consider these 7 values here, what's the highest amount that each of these occurs in each line? So for example, we definitely need 2 5s, because for this statement to be true, he needs to have 2 5s out of the 6 notes in total. So I'll say that he needs at least 2 times 5. We can then say he needs at least 2 20s, so 2 times 20. And then there's only one 10 that occurs in both, so we can say that he needs at least 1 10. So at least one £10 note. We can then move on to the second set of statements, which are the ones that he cannot make. So he cannot make £25 with 3 notes. So again, let's consider, how can we make £25 with 3 notes? Well, we'd need 10, 10 and 5, okay? So he cannot have, out of his 6 notes, he can't have a 10 twice and a 5, okay? We'll then do the same for the final statement. He cannot make £25 with 4 notes. So how can we make £25 with 4 notes? We can do it with a 10, a 5, a 5 and a 5, okay? So what can he not have out of his combination of 6 notes? He cannot have 2 10s. Now we take the lowest amount each one occurs this time. So he cannot have 2 10s, because if he did, as he already needs 1 5, well, he actually needs 2 5s. This is here no matter what. The 5 is going to be there no matter what. So therefore he can't have 2 10s. So he can't have 2 times £10. And then for the remaining statement, he's going to have a 10, because the 10 is needed from the must-have column, whereas the 3 5s, we don't need 3 5s, we only need 2, so we can say he cannot have 3 5s as well. So he cannot have 3 times £5. So if we think about what the 6 notes actually are, we know that they are definitely these here. So we can say definitely a 5, a 5, a 20, a 20, and then a 10. Now this is only 5 notes, so what can the 6th note possibly be? So we've already got 1 10, so we can't have another. We've already got 2 5s, so we can't have another. So the only note that it can possibly be is a 20, as it doesn't fit into any of these can't have criteria. Okay, so question 9, we are told that a music app has a shuffle play function, and this means of course that songs are played in a random order without repeat. So Ruth puts 10 songs on shuffle play, and one of them is her favourite song, and we need to write down the probability that her favourite song plays first. So the key pieces of information: 10 songs, one of them is her favourite, so there's a chance that 1 out of the 10, which is her favourite, plays first. So we can say that the probability that her favourite song plays first is 1 out of the 10 songs, so 1/10, and the answer is of course 1/10. Question 9b, we are told that Ted puts songs A, B and C on shuffle play. List all the possible orders of songs A, B and C, and the first one has been done for us. Okay, so let's keep A in position number 1. So we then have A, C, B. We can then put B in position number 1, because we've done all the combinations possible with A first, being ABC and then ACB. So if we put B in position number 1, we can then have BAC, and we can also have BCA. So as we can see, we've got 2 possibilities with A first and 2 possibilities with B first. So of course there's going to be 2 possibilities with C first, so we'll put our 2 C's down in position number 1. We can then have C, A, B, or C, B, A. And these are all the possibilities of the songs being played on shuffle mode. Okay, so question 10, we are given a scale drawing of a Ferris wheel and a building. Okay, we are then told the Ferris wheel has got a height of 130 metres, and we need to work out the height of the building. So the first thing to do in the exam is grab your ruler and measure this length from point to point of the arrow, and when you do that you find out this is equal to 2 centimetres. Next thing to do is work out the height of the building with your ruler, so from the very base on the line all the way to the tip, and this gets you 10 centimetres. So what we can then say is the building is 5 times the height of the Ferris wheel. So to show the examiner we know this, what we do is our 10 centimetres divided by 2, which is equal to 5, as the building is 5 times the height of the Ferris wheel, and therefore if the Ferris wheel has got a height of 130 metres, what we can then do is our 5 times the height of the building to the Ferris wheel, so 5 times our 130 metres, which will get us 650 metres, which is the height of the building. So again, what we've done here is we've worked out how much bigger is the building than the Ferris wheel, and it's 5 times bigger, and then we multiply the 5 times bigger building by the height of the Ferris wheel, which is 130 metres, as we've done here, and we get 650 metres. So 650 metres is the final answer. Question 11, we are told Jo has a full cup of coffee, as shown here, and she drinks some of it, and we are left with this here, and she says that half of the coffee is still in the cup because 5 centimetres is half of 10 centimetres. Is she correct? Yes or no, and give a reason. I mean, she's obviously not correct because this is not a cylinder, it's a section of a cone. So if you imagine a cone, it'd be like this, and the top vertical half has got a greater volume than the bottom vertical half, as the radius of the base decreases as we go down, leading to a smaller volume here than there is up here. So what we can say is she correct? No. And we can say the reason is because, so we'll just say because the volume in the vertical top half of the cup is greater than the bottom half. And that will be enough to get the 1 mark for that question. Question 12, we are told a takeaway sells pizzas that are 10-inch and 12-inch, and here's some information about pizzas sold in 2 weeks. So we've got week 1 and week 2 data down below. So for part A, we are told in each week a proportion of the pizzas sold were 10-inch, and in which week was this proportion greater. So we need to work out in which week, 1 or 2, was the proportion of 10-inch pizzas sold greater. Okay, so for week 1, the amount of 10 inches sold was 512. So we can say week 1, we've got 512 pizzas that were 10 inches out of a total of 743. So we can do 512 divided by 743 to find the fractional amount of 10-inch pizzas that were sold, and then to find a percentage we can do times by 100. Let me just grab my calculator. When we do this, what we get is 512 divided by 743 times by 100, and that is equal to 68.9%. And then for week 2, we'll do the same calculation. So the amount that was sold that were 10 inches, which is 758. So we've got 758 divided by the total amount of pizzas sold, which is 1065. And then times by 100 to get the percentage. And when we do this, what we obtain is 71.2%. So we can therefore say, week 2 has higher proportion. So week 2. Question 12b, we are given some information about the profit and loss of the takeaway for each pizza. In week 1, the total profit was £1,895.55p, and at the end of week 1, £175 was spent on adverts. So the question is, was the increase in profit, in week 2 more than the cost of adverts? And we need to show our working. So we need to work out how much profit was made in week 2. So here's some data here about the profit and loss for the pizzas. So for a 10-inch normal price, it's £3.74 profit. So £3.74, and then the amount of pizzas that were sold at this rate, we've got 10-inch and then at normal price, so 396. So multiplied by 396. Okay, we've then got 12-inch pizza at £5.29 profit, normal price. So we've got £5.29 multiplied by 12-inch at normal price, which is 164. Okay, so we've then got the losses. So we've got on the offer price for 10-inch a 51p loss, so we've got negative 0.51 multiplied by 10-inch for offer, so 362. And we've then got the other offer, which is a 4p loss for the 12-inch on the offer price, so we've then got negative 0.04 multiplied by the 12-inch on the offer, so 143. Okay, so we need to work out all of these values and then add them together. So when we work all of these values out, we get £1,481.04 for the top one. We then get £867.56. For the losses, remember this is negative, so we get a loss of negative £184.62, and we then get a loss of negative £5.72. So what we have to do from this point is we have to add all of these values together. So when we sum these values, so I'll just put sum values, what we obtain is £2,158.26. Okay, and if we then take away our price for the adverts, which is £175, so if we then take away £175, what we are left with is £1,983.26, and therefore the profit is greater. So the profit in week 1 was £1,895, and this week it's almost £100 more. So what we can then say as a concluding statement is, just change colour, we can say yes, and we can say £1,983.26 is greater than 1,000, the previous profit, £1,895 and 55p. So yes, it is more, so we just put yes. Okay, so for question 13, we are told that a car is travelling 3.5 miles in 5 minutes, and we need to work out the average speed in miles per hour of the car. And this is worth 3 marks. So the first thing to do is write down our equation, which is speed is equal to distance divided by time. And we know we need to work out speed, so we need to find out what the distance and the time is. So we can then say speed is equal to our distance, which is 3.5 miles. So 3.5, then it's divided by the time, which is 5 minutes. But we need to convert this into hours, because the units that we need the speed in is miles per hour. Okay, so 5 minutes in hours, what we do is we take the 5 divided by 60, and this is equal to 1 over 12. So 5 minutes in hours is 1/12 of an hour. So we then divide our 3.5 miles by 1 over 12. And when we do this, we get the speed to come out at 42 miles per hour. So the answer is 42. Question 14, we are told that a triangle has got a base of 9 centimetres and a perpendicular height of 5.6 centimetres. Now we need to work out the area of the triangle. So the area of the triangle, we'll call it A, is equal to half multiplied by the base B multiplied by the height H. So we can then just sub in our values, where A, the area, is equal to a half multiplied by the base, which is 9 centimeters, multiplied by the height, which is 5.6 centimeters, and this comes out at, just use my calculator, so we've got a half multiplied by 9 multiplied by 5.6, so this is equal to 25.2 centimeters. It doesn't state if we need a certain number of significant figures, so we'll leave the answer in its full form at 25.2 centimeters squared. That should be squared there. There we go. Question 15 is a bit of a weird one, and it's worth 3 marks. We have 4 positive whole numbers that add up to 36. One of the numbers is a multiple of 7, and the other 3 numbers are equal, and we need to work out the result when the 4 numbers are multiplied. So the first thing to do is we need to work out what the 4 numbers actually are. So they add up to 36, 1 is a multiple of 7, and 3 of the numbers are equal. So we're going to use trial and error to find out what all the numbers are. So let's go for the first multiple of 7. I'll just write down here, multiples, if I could spell, multiples of 7, and then we'll put the first few, so 7, 14, and 21. Okay, so let's use 7 first. We'll do our 36, this is attempt number 1, so 36 take away 7 is equal to 29, and then we try and divide 29 by 3 to find the 3 equal numbers, and we can't do that, so it doesn't work. Okay, we move on to our second attempt. So the second attempt, we do 36 take away 14, which is now equal to 22, and then we do 22 divided by 3. Again, doesn't give a whole number, so we say no, we can't do this. We'll then move on to our third attempt. So this time we're going to use 21, so 36 take away 21 is equal to 15, and we can see that 15 does divide by 3 to give 5. So therefore the numbers, choose this colour, therefore 4 numbers are, so we've got our 21, 5, 5 and 5, so we can then say therefore 21 multiplied by 5 and again is equal to, just grab the calculator, so 3 5s multiplied by 21, that is equal to 2,625, so therefore the answer is 2,625. Okay, so question 16 is pretty straightforward. It's simply to draw a sketch of the triangle shown, which is ABC. So we need to draw this triangle accurately. Okay, we are already given the length of AB to begin with. So the first thing to do to draw this triangle accurately is to draw the length of AC, but we need to make sure that it's at 37 degrees. So in the exam you need to grab your protractor and measure 30 to 37, 37 degrees from the point A. So let's say that's 37 degrees roughly, and you are allowed to have a range of values for 37 degrees. So the values that are accepted are between 35, so you can have between 35 to 39 degrees, they are accepted values. And then once you've drawn our length here, which is AC, so once this length is drawn, we need to make sure this is between a certain set of values as well. So it's meant to be exactly 8 centimeters, but again you can have a range. You can have between 7.8 to 8.2 centimeters. These are accepted in the exam. And the final thing to do is to link up the sides CB, and once you've done that, that'll be enough for the 2 marks for this question. Question 17 is a bit of algebra, and we need to simplify 7x minus 3x minus 2 in brackets. Okay, first thing to do, using the rules of BIDMAS, is to solve the brackets first. So when we solve this, we get 3x take away 2x, which is simply equal to x. So then what we've got after we've worked out the brackets is 7x minus x, and this is of course equal to 6x, so we just circle 6x. Okay, so question 18 is a really easy question. We are told a competition took place in 1983, and it takes place every 6 years, and we need to circle the year which will also take place in out of these 4 options here. So what we do is we go to our calculator and we type in 1983 for 1983 of course, and then we do plus 6, and this will give us of course 1989. Are you Siri? And then once we've got our 1989, what we're going to do is click answer in our calculator and then plus 6 and then press equals. So I'll just do this now. So we've got 1983 plus 6 equals, then we press answer, plus 6 equals, and that gives us of course 1995. Then we press equals again, 2001, and again, and we keep pressing equals until we see one of these 4 values. So again, we're on 2025 currently, then we get 2031, 2037, so we know it's not this one here. Press it again, 2043, nope. 2049, yes, so we get this one. So the answer is 2049. Question 19, we are told in an election there were 4 candidates, J, K, L and M, and Fran is drawing a pie chart to show the results, and the sectors for J and K have already been done. So we can see the sectors for J and K here already done. We are then told that twice as many people voted for L as they voted for M, and we then need to complete the pie chart. So the portion which is L and M is this portion here in terms of degrees of the circle. So to work out what this is in degrees, what we do is take 360, the amount of degrees in the circle, and we take away the already known values for J and K, which is 72, and on 90, the right angle, 90 degrees. So 360, take away 72, take away 90. I'll just grab my calculator. This is equal to 198 degrees. Okay, so all of this is 198 degrees. We then need to work out what portion is for L and what portion is for M. So if we make a ratio of L to M, we'll just do that. We'll do that here. So our ratio of L to M is in the ratio of 2 to 1, as twice as many people voted for L as they did for M. So we can say this is a 2 to 1 ratio. So therefore we've got 3 parts in our ratio here. So if we divide our 198 degrees divided by 3, this works out what one individual part is, which will be the value for M in terms of degrees. So we do 198 divided by 3, and this is equal to 66 degrees. So our new ratio of L to M is going to be 66 degrees here, and multiply by 2 to find the ratio of L, as it's twice M. What we get is 132 degrees for L. So therefore we just have to draw these onto our pie chart. So firstly we'll draw on M, which is 66 degrees. So if we go to 90, that's there. So 66 is roughly a third of the way back. So about here. So I'll then say this is 66 degrees and this is L, not L, this is M. And therefore our remaining our remaining portion of the pie chart in terms of degrees is 132, and this is L, and that'll be enough for the 3 marks. So in part B of question 19, we are told in total 16,200 people voted, and we need to work out how many voted for J. So we know that our pie chart has got 360 degrees here, so the first thing to do is to work out how many people represent 1 degree. So to do this, we take the amount of people, 16,200, and divide by 360 to work out how many people are in a 1 degree sector of the pie chart. So if we put this into our calculator, we get 45. So 1 degree is worth 45 people. And we then need to work out how many degrees J has got. So J has got 72 degrees. So therefore we multiply our 45 people by the 72 degrees for J, and when we do that we get 3,240, which is the amount of people. So the final answer is 3,240 people. So for question 20, we are told the probability that A is the outcome of an experiment is 0.2, and we need to circle the probability that A is not the outcome. So what we need is anything but A, where A is 0.2. So anything that isn't A As all probabilities sum to 1, we do 1 take away 0.2, which is equal to 0.8, so therefore the answer is 0.8. Question 21, again there's only worth 1 mark, so it's fairly easy. We need to rearrange a equals 2f to make f the subject. So the first thing to do is to is to divide both sides by 2. Okay, to get rid of the 2 in front of the f here. So dividing both sides by 2, I'll just write it here, e equals 2f, and we then divide both sides by 2. We are then left with e over 2 is now equal to f, and we can see that that is the final one here, f equals e over 2. Okay, so for question 22 we are given a rule for a sequence, which is after the first 2 terms, each term is half the sum of the previous 2 terms, and we are given the first 3 terms in the sequence, and we're then told to show that the 6th term is the first one that is not a whole number. So essentially all we have to do is follow the sequence up to the 6th term and see what we get. So what we do is each term is half the sum of the previous 2 terms. So what we need to do is sum the previous 2 terms, which is 10 and 6. So we do 10, so this is for term number 4. So 10 plus 6 divided by 2, which is 16 divided by 2, which is 8. So we then fill in our 8. The 5th term is going to be 6 plus 8 divided by 2, which is 14 divided by 2, which is 7. So that's our 5th term, and our 6th term, we do the same thing again, we do the previous 2, so 8 plus 7, all over 2, which is equal to 15 over 2, which is equal to 7.5. So as shown, the 6th term is the first one that is not a whole number. Okay, so question 22 part B says a different sequence follows the same rule as in part A, and the first term is 4, third term is 9.5, and we need to work out what the second term is. So let's just remind ourselves what the rule was. It's each term is half the sum of the previous 2 terms. So let's fill this rule in as best we can for question 22b. So the third term, 9.5, is equal to the previous 2 terms, so 4 plus our second term. I'll just call it second, and then divided by 2. So all we have to do is rearrange this formula to find out what the second term is. So the first thing to do is multiply by 2. When we do this, we get 19 is equal to 4 plus the second term. And then the final thing to do is to take 4 away from both sides to get 15 is equal to the second term. So the second term is 15. Question 23, we are told in a group of 20 people that 7 own a dog, 3 own a cat and 12 do not own a dog or a cat. And Aidan shows this information on a Venn diagram. And we need to make 2 criticisms of his Venn diagram. So from observation straight away, this number 12 should be inside of the box. So we can say that the number 12 should be inside the rectangle. So 12 should be, I'll just underline as well, should be inside the rectangle. And a second one, if we just actually add up the values, so if we do 12 plus 7 plus 3, we get 22, but there's, well, 20 people in the group, so we can say that the total of the numbers in the diagram adds up to 22, not 20. And there's a couple other things that you can say, and these are: the universal set has not been defined, and another one would be there should be some numbers in here in the overlapping section. Specifically, there should be 2 people in the overlapping section. Okay, so question 24, we are told that A is a common factor of 72 and 120, and B is a common multiple of 6 and 9, and we need to work out the highest possible value of A over B. So the first thing to do is to write down all the common factors of 72 and of 120 as well. Okay, so once we've done that, what we need to do is find the highest common factor which occurs for both 72 and 120. And this is because if we consider A over B, we need A to be as big as possible and B to be as small as possible in order for this to give the highest value of A over B. So we need the biggest value of A, which is the highest common factor of 72 and 120. So we just look at the values that we've got here of all the common factors. What we can see is that the highest value that occurs in both sets is the number 24. So this is our highest common factor, so we can say that A is equal to 24. Okay, so for B, what we need to do is write down the multiples of 6 and 9, okay, to find a common multiple. So if we write down multiples of 6, we've got 6, 12, 18, 24, 30, 36 and 42, and then we'll do the same for 9, so we've got multiples of 9, and they are 9, 18, 27, 36 and 45. Okay, so remember from before, we need to find the lowest possible value of B, so the lowest possible value of the common multiples of 6 and 9. So if we look for the lowest value, we can see that it's 18 as they appear in both lists. So if we circle our 18, we can then say that B is equal to 18. So therefore we can then say that let me just move this over here. So we can then say therefore A over B is equal to 24 over 18, which is equal to 12 over 9, which is equal to 4 over 3, or we could have 1 1/3, but I'll leave it as 4 over 3. Okay, so question 25, we are told A and B are similar shapes and B is an enlargement of A with a scale factor of 1.5. So we'll highlight this straight away. So we need to work out the values of X, H and W. So the easiest one to do straight away is X, because no matter how much we enlarge shape A, the angles, whether it be this angle, or the angle X, will always stay the same. So we can say straight away that X is equal to 54 degrees. Okay, we'll then move on to let's do H next. So B is 1.5 times greater than A. So what we can then say is this length here, 5, in shape B, it's going to be 1.5 times the length as it was in A. So to work out what H is, all we have to say is H is equal to 5, the initial length, multiplied by the scale factor, 1.5, and this is equal to 7.5, and the units are centimetres. We'll then move on to the final length, which is length W. So W is in the smaller shape, so this means that 9 is 1.5 times the length as it is in shape A. So we can say W is equal to, we've got, actually let me rewrite this, so we can then say that W multiplied by 1.5 is equal to 9, so therefore W is equal to 9 divided by 1.5, so W is equal to 6, and they are the three missing lengths, so we'll just write them down on the answer side. So we've got, use a neutral colour, we've got 54 degrees, we've then got, for H we've got 7.5 centimetres, and for W we've got 6 centimetres. Question 26, we are given two investments A and B, and for investment A we are told that we get £150 per month for 2 years, and then 2.5% interest is added to the total amount saved. Okay. Investment B, we invest £3,500 and the compound interest is 3% per year. After 2 years, how much more is investment B worth than investment A? So let's work out how much investment A is worth after 2 years straight away. Okay, so we do our £150 per month here, so our 150, and then multiplied, let's do that in red as well, multiplied by the 12 months per year, and then we've got 2 years of this, So if we put this into our calculator, we get £3,600, and then we've got a 2.5% interest is added to the total amount saved. So we then do our 3,600 multiplied by 1.025, and this is equal to £3,690, and this is for investment A. So if we move on to investment B now, we can take our initial 3,500 and it's being multiplied by 3% per year, so we can do multiply by 1.03%, not percent, 1.03, which is equal to our 3%, and then it's for 2 years, so we raise this to the power of 2, and if we put this into our calculator, 3,500 multiplied by 1.03 to the power of 2, we get 3,713 £13 and 15p. So to find the difference, or how much greater B is than A, we do our £3,713 15p and take away 3,690, and this leaves us with £23 and 15p. Okay, for question 27a, we are given two lines, y equals 3x plus 7 and 2y take away 6x equals 8, and we need to show that they are parallel, okay, and don't use a graphical method. So the first thing to do is to find the gradient of, I'll call this line 1 and I'll call this line 2. So to find the gradient of line 1, we need to get y on its own, which it already is, so we can say that y equals 3x plus 7, so therefore gradient is 3. Then for our second line, we need to work out the gradient again, so we need to get y on its own just to be y, not 2y, so we can do some rearranging. So we've got 2y take away 6x is equal to 8 first of all, we then plus 6x to both sides to get 2y is equal to 8 plus 6x, and therefore y dividing both sides by 2 is equal to, we'll just swap these the numbers in the x over as well to make it easier for ourselves, is equal to 3x plus 4. So we can see the gradient is 3 as we've got a 3x, so we can say therefore gradient is also 3. And then we need one concluding statement, so we can say for lines to be parallel, the gradient must be the same. And that'll be enough for the 3 marks for that question. So for question 27 part B, we are given a point -5, -6, and we need to say if it's above, below or on the line y equals 3x plus 7. And we can't use a graphical method either. So what we need to do is we need to sub in our x coordinate, -5, into our equation of the line. So when we do that, what we get is, we can say first of all, when x is equal to -5, we've got y is equal to 3 lots of our -5, then we've got plus 7, so y is equal to -15 plus 7, and therefore y is equal to -8. So if we compare this to our coordinate that we were given, -5, -6, we can see that this is more negative, so therefore this means that the actual coordinate, we'll just write the coord when x is equal to -5 for the line, then we'll just state the equation of the line, so it was y equals 3x plus 7 is, and then we'll give the coordinate, so it would be -5 and then it would be our -8 here. So we can then say therefore the point which was in the question initially, minus 5 minus 6. If we consider the actual point, which is minus 5, negative 8, negative 6 is less negative, so it's going to be higher up, so therefore it's going to be above the line. And that's 2 marks. Question 28, we are told that the cost of a ticket increases by 10% to £19.25, and we need to work out the original cost of the ticket. So if the new cost is 10% greater, this means that £19.25 is equal to 110% because of the 10% increase. So 110% of original. So we can then say, therefore, 19.25 divided by 1.1, which is equal to our 110%. This is equal to original price. So again, therefore, £19.25 divided by 1.1 is equal to, just grab the calculator, that is equal to £17.50, which is our original price, £17.50. Okay, so question 29, we are given the nth term of a sequence, which is 12n minus 5, and we need to work out the numbers in the sequence that have 2 digits and are not prime. So the way I'm going to work this out is by first of all writing down 12n, so we can say 12n is equal to, and all we have to do is write down the multiples of 12, so we've got 12, 24, 36, 48, 60, 72, 84 and 96. I'll just move all this along so that's inside the rectangle. There we go. And then the next thing to do is write down our 12n take away 5. So we can then say 12n take away 5 is equal to, and all we have to do now is take 5 away from each of these values. So taking 5 away, we are left with 7, 19, 31, 43, 55, 67, 79, and then 91. Okay, so we now need to see which of these numbers are prime, and there should be 2 that aren't prime. There should be some 2-digit numbers that aren't prime, and we just need to say what they are. Okay, so if we go through each of them one by one, we can see the number 7 is prime, 19 is again prime, 31 is prime, 43 is prime, 55 however can be divided by 11, so it's not a prime number, 67 is prime, 79 is prime, and 91 is the only other number that is not prime as it can be divided by 7, so the 2 numbers are 55 and 91 are not prime. And again, just write these on the final answer line, so 55 and 91. Question 30, part A. We need to work out what a plus b plus c is, where a, b and c are given here. So to work out a plus b, what we need to do is essentially add the 6 and the -1, as well as the -10 and the 2. So we can say a plus b is equal to, so we've got 6 plus -1, which becomes just take away 1. Then we've got -10 plus 2, so this is equal to 5, and then we've got -8. So to then work out a plus b plus c, we use the a plus b we've already worked out from here. So this is equal to our 5, -8, and then we've got plus, so I'll do it the same way as before. So then all we have to do is plus -4 and plus 7. So when we do this, 5 plus -4 just becomes 5 take away 4, and -8 plus 7. There we go. So when we solve this, we get 1 and then -1. So we'll just write this in our answer box, 1, -1. Question 30, part B, we need to show that a plus 2c is equal to kb, where k is an integer. So what we need to do is work out what a plus 2c is first of all. So a is, I'll do some green, a is here and c is here. So we've got A, which was 6, negative 10. And then we've got plus 2 lots of C, which is negative 4, 7. So this is equal to A, 6, negative 10, plus 2 times negative 4, and then we've got 2 times 7. So what we have is negative 8, 14. And when we work this out, we've got negative 2 on the top, and then we've got 4 on the bottom. So if we compare negative 2, 4, so we'll just write this here, negative 2, 4, this is equal to, if we look at what B was, it's negative 1, 2, so it's equal to, let's have a look at the top, negative 2 to negative 1, so the answer we've got is 2 times bigger, or 2 times smaller as it were, because it's a negative, and then 4 and 2, there's a factor of 2 difference again, so we can say that it's equal to 2b, so therefore k is equal to 2.